Hello from MR-CFD Geometry Modeling and Mesh Generation training videos. In this video, I want to teach you how you can draw the geometry and its computational domain and generate the mesh for the SR-71 Blackbird aircraft. Because the flow in the simulation is compressible, now I want to say something about the compressible flow. Actually, a compressible flow is a branch of fluid mechanics that deals with flow having significant change in fluid density. While all flows are compressible, flows are usually treated as being incompressible when the Mach number, the ratio of the speed of the flow to the speed of sound, is smaller than 0.3, since the density change due to velocity is about 5% in that case. The study of compressible flow is relevant to high-speed aircraft, jet engines, rocket motors, high-speed entry into a planetary atmosphere, gas pipelines, commercial applications such as abrasive blasting, and many other fields. Actually, there are several important assumptions involved in the underlying theory of compressible flow. All fluids are composed of molecules, but tracking a huge number of individual molecules in flow, for example, at atmospheric pressure, is unnecessary. Instead, the continuum assumptions allows us to consider a flowing gas as a continuous substance except at low densities. These assumptions provide a huge simplification which is accurate for most gas dynamic problems. Only in the low density realm of Rayfield gas dynamics does the motion of individual molecules become important. Because in this project, the supersonic flow around this geometry is investigated, it is necessary to give you some explanation about the supersonic flow. A flow field is defined as supersonic if the Mach number is greater than 1 at every point. Supersonic flows are frequently characterized by the presence of shock waves, across which the flow properties and streamlines change discontinuously, in contrast to the smooth continuous variations and subsonic flows. About the Lockheed SR-71 Blackbird. Actually, the Lockheed SR-71 Blackbird is a retired long-range, high-altitude, Mach greater than 3 strategic reconnaissance aircraft developed and manufactured by the American Aerospace Company. And the SR-71 has several nicknames, including Blackbird and Habu. The SR-71 was developed as a black project from the Lockheed A-12 reconnaissance aircraft, and the shape of this aircraft was based on that of the Lockheed A-12, which was one of the first aircraft to be designed with a reduced radar cross-section. Initially, a bomber variant of the A-12 was requested by someone before the problem was focused slowly on reconnaissance. The SR-71 was longer and heavier than the A-12, allowing it to hold more fuel as well as a two-seat cockpit. Mission equipment for the plane's aerial reconnaissance role included signal intelligence sensors, a side-looking airborne radar, and a camera. During missions, the SR-71 operated at highest speed in altitude. Mach is equal to 3.2 and 85,000 feet and 2,005 meters, allowing it to outrace or entirely avoid threats. Okay, now in ANSYS Worker software, double-click on the geometry under the component system to create the geometry block, and then right-click on this geometry, and from import geometry, open the base geometry. And then double click on the geometry to open ANSYS space claim software. Okay, here at first you must create a computational domain. For this purpose, with rectangle tool, create a rectangle. You can switch between these dimensions by tab key on your keyboard. By the dimension tool, specify the length for each edge. Click on the enter key on your keyboard. Now specify the distance between the edge and axis. Follow my cursor point. Click on the end of sketch editing. This is a surface without any thickness. Okay, enable these components to see the Blackbird. As you can see, the different parts of this plane are separated. Using the combine command, I want to make all the bodies one. And the next step, I'm gonna pull this surface to make a computational domain. Click on the no merge because I don't want to merge the main body and this domain. Okay, considering that the flow around the plane is to be investigated in this project, it is necessary to subtract the solid part of the plane from the computational domain. Using combine command, you can do it. Now you can see 3 part under the geom base. Okay, now just delete the extra parts, hide this face to have better see, and then right click on this component and click on the delete. Also the solid part of the aircraft. And right click on the screen and click on the show all faces. Return to the ANSYS workbench software and double click on the mesh under the component systems and drag and drop the geometry from the geometry block to the mesh block and double click on the mesh to open ANSYS meshing software. Okay, here click on the mesh and change the physics preference to the CFD at first, and then change the element size to the 0.2 meter, and from quality options set the smoothing to the high, and then click on the now you have to define a name for edge boundary so that when you open the mesh in the ANSYS Fluent software you can specify the boundary conditions easily. For this purpose, right click on each surface and select create named selections, specify the name and then click on the OK. As can be seen, I have defined the outlet, inlet, symmetry and aircraft before. For the last step, in ANSYS meshing software, you must export the mesh file for Fluent software. From File, Export. Here specify the file name and then specify the path. To benefit from MR-CFD services including simulation, consultation and training, visit our website www.mr-cfd.com and contact us via info@mr-cfd.com.